Hey guys, Rohan Shah and welcome to my YouTube channel. Let's start today's problem of the day on geeksforgeeks. Okay, so what is today's problem of the day? It is shortest path using almost one curved edges. Okay, so what exactly the question is? Given an undirected graph of n vertices and the list of m edges in a graph, and for the each pair of vertices they are connected by edges. They, there are two edges between them, one curved edge and one straight edge. So W1 is nothing but the weight for the straight edge and W2 is the weight for the curved edges. Okay, you are given two vertices A and B. You have to go from A to B through a series of edges such that in the entire path you can use at most one curved edges, and your task is to find the shortest path between A and like between A to B. Okay, so here in the example we can see we have four vertices and four edges. Okay, so we can say we have four straight edges and four curved edges. Okay, so here the graph given 1, 2, 3 and 4, and as mentioned the W1, this is the third character, or we can say the third number of this particular array, is nothing but the weight of the straight edges, and the fourth one is nothing but the weight of the curved edges. Okay, so what exactly we need to find here? We need to go from here. Okay, let's take this example. Here they given us we need to go from 2 to 4. Okay, so if we are going from 2 to 4, this is undirected graph. So there is no direction we can go from any of the vertices. Okay, so if we are going from 2 to 4, then we have this one edge, the weight is 6. Okay, then the one curve edge is the weight is 5. Okay, but what is the question? We need to go with the shortest path. Okay, so weight should be shortest, and at most we can use the one curve edge. Okay, so if we are going from 2 1 4, then it's 1 and 3, then the total weight is nothing but the 4, but we can still use one curve edge. Okay, so here at this green path shows 1, and from 1 to 4 we are using this curve edge. The weight of this curve edge is nothing but 1. So at the end we'll get the shortest path, the straight edge weight is 1 and the curve edge weight is 1. So at the end we reach from 2 to 4 with just weight of 2. Okay, so this is nothing but the shortest path. Okay, the same we need to find for all the test cases, and for that we need to write a code. Okay, so first of all, what we need to do here, first one function we need to use, we need to write to find the shortest path, which is nothing but we have one algorithm, Dijkstra algorithm. Okay, from that we can find the shortest path between any of two edges by giving the weights and the graph. Okay, so I already write a Python code here, and for that I already write this function to find the distance. Okay, so I'm this is this is the common algorithm, so I'm not explaining that. So I am just mainly going with the function which we write to find this thing. Okay, how to find the curve edges and how to find the straight edges. Okay, so first of all we'll get one null graph. Okay, and in that we'll put the weight based on the number of edges. Okay, sorry, not number of edges, but we can say the weight with the appropriate edges. Okay, so the better if I run this and we'll traverse that now, then we'll get a better understanding. Let me first compile it. I write a multiple print statement to understand this code. Okay, so from that we can understand this better. So first, as we can say, I define just a null graph. Okay, as we have four edges, so it is we can say null graph for the four edges, and then we'll just put some values in that. And how we'll put the values in that? Like we can say age associated with the weight of that vertices. Okay, so we can say let's say this is the graph. I just put it here in the page. Okay, and we need to go from first we'll traverse this u and v. Okay, so 1 2 1 3 1 4 and 2 4. Okay, so what are the weights? Okay, we'll just put that here. Okay, so let me put it like this is nothing but the 1. Okay, 2 3 and 4. Okay, then we just mentioned like 1 2 3 4, but here we are using this. So it is in the index starts from 0. So let's consider this as 0 1. This is nothing but 2 and this is 3. Okay, so now let's traverse this code. If we are putting 1 2 in this first for loop, then we need to put at 0th index and the value should be 1. This is v is nothing but the 2, so 2 minus 1 1 and the weight is nothing but 1. So we need to put here 1 1. Okay, so we can say it like 1 comma 1. From distance from 1 to 2 is nothing but 1. Okay, here we consider 0 to 1 because every time this index comes in the picture, then there will be a minus 1. Okay, the same way, if we are putting like 2 to 1, the same will get this 1. Okay, so here we'll just put it like same 0 1 0 comma 1 because now it's 0 is nothing but the 1. We can say here 2 to 1 we are going and the weight is 1. It's nothing but this the second line we are appending into the v1, sorry, v minus 1. Okay, in the same way if we are taking for 1 3. Okay, so for 1 3 if we are putting here, then we'll got 2 2 because the weight is here is nothing but the 2. Okay, so if we are putting, then this will get 2 2. Okay, and same way here we will get it like if we are putting 1 2 3. Okay, then weight is 2. Okay, but if we are putting here, then it should be uh, graph of 2 and the value should be 0 comma 2. Okay, then this will be 0 comma 2. Okay, now for the next 1 comma 4, even for that we'll get it like weight is 3, so we'll get it like 3 comma 3. Okay, 3 comma 3. In the same way here we'll get it like weight is 3. Okay, still we'll get from 0 comma 3 because here we consider like this is the 3, right? So we can say 0 is nothing but 1. So if we are going from 4 to 1, then this is the one edge with the weight of 3 that we can consider from here. Okay, and the last is nothing but 2 comma 4. If we are putting 2 comma 4, then we'll get it like 2 minus 1. So we need to append this in the first part, and it is what we can say the value should be 3 comma 6 because weight is nothing but the 6. Okay, so here we can put it like 3 comma 6. In the same way, if we are putting going for this reverse like 4 2, then we need to give it like in the third part of this array we'll get it like 1 comma 6. So here we'll get it like 1 comma 6. Okay, so this is nothing but the representation of this whole graph in terms of array uh, with just the straight edges. We are not considering any of the curve edges here. Okay, so this is nothing but the result we can see here we are getting while printing this graph. So it is nothing but 1 1 2 2 3 3 what we are getting here, and the second is 0 1 3 6 0 1 3 6. The next is 0 2 0 2, and at the end 0 3 1 6 0 3 1 6. So we can say this is the graph we are getting, and we are giving this into the Dijkstra algorithm to get the shortest distance from particular two values a and b. but as I said, we are putting here in the list format, so we are just giving it -1, a -1 and b -1. Okay, so when we are printing this, then we'll from that Dijkstra algorithm we'll get two distance, like distance a and distance b. So from particular a value, the shortest distance to the all other nodes, and distance b, like dist b is nothing but the shortest value of all other nodes from the value b. Okay, so what is the value a and b? It's 2 and 4. Okay, so if we are considering here, let me minimize here. So if we are considering here, let's say first 2. Okay, so what is the shortest distance between 2 and 1? So it is nothing but the 1. The same we are getting here, the first value. Okay, and the 2 to 2 is what, obviously it is 0. Okay, then 2 to 3 is nothing but 2 plus 1. Okay, so that is nothing but the 3 we are getting, and 2 to 4 is nothing but 1 plus 3. So that's nothing but the 4 we are getting. Okay, in the same way we are finding the shortest distance from this 4 to all other nodes. Okay, if we are getting 4 to 1, okay, here we are just considering straight edges only. So 4 to 1 is nothing but the 3. What we are getting here, it's 3. Okay, then 4 to 2, it's nothing but 6, but we have another shortest distance 3 plus 1, so that is 4. Okay, and 4 to 3 is 3 plus 2, it's 5, and 4 to 4 is but obviously 0. Okay, so we can say that this way we are just getting the shortest distance from the Dijkstra algorithm. Now the part comes when we need to consider this curve edges. Okay, so we already have a distance, we'll just store that one distance into the result. Okay, and what we can say, which distance will store. Okay, we have the shortest distance, so we have 2 to 4. So whatever the distance we are getting from 2 to 4 from the Dijkstra algorithm, with the straight edges we are storing that into the results temporarily. Okay, and that is, if we are not getting any curved edges, then we'll get it like what we can say, that is nothing but the result we can say. Okay, okay, so now we'll find like which curve edge we can use here. Okay, so here I'll just use the another for loop. Okay, with the weight 2, we are not considering weight 1 because like now we just need to find the weight 2, and we are just considering the curve edges because we already have a distance with the straight edges. Okay, so this is nothing but the result. Will store this 4 into that. Okay, and now we'll just find the minimum of the result, either the distance from particular this vertex, particular this edge, to what we can say, this another edge, what is given here, u to v. Okay, and with the curve edges. Okay, so here we can say what is the distance a from 1 to 1. Okay, so we can say two, this is distance is nothing but the 2 to all other edges. Okay, so the first it's 1. Okay, so we are just getting 2 to 1, we are getting it 1. Okay, but the curve edges if we are getting, then it is 4. So definitely that will be more than this resultant one. Result is nothing but 4, and here we just get it like 1 plus 4 plus something else. Okay, so that will be more. So we are just considering this result as the result. And the same way, if we are getting from b, okay, so it's nothing but the 3 plus it's 4, so it is also more than this 4 we already have. Okay, so in that case we can say we'll just put this result value whatever the previous result value we have. Okay, but when we just reach at this third step, we'll get it like curve, like we'll have this age is nothing but 1, sorry, not age, but curve age, what we can say, the curve weighted is nothing but the 1. Okay, so in that case if we put it like here, so it is like distance of a of 0 is nothing but 1 plus weight 2 wt is nothing but the 1, it's 2 plus here if we consider distance b of this 3. So if we are getting 0 1 2, so that is nothing but the 0. Okay, so if we are considering 4 and 2, then the minimum value of this result will be 2. So this is the case where this all the game changes, and we'll consider this what we can say curve age. Okay, and we'll just put it like value of minimum of 4 comma 2 into the result. Okay, and the same goes for the next, and that will not change. Okay, so now we'll just change from what we can say 4 to 2 with the one curve edges, sorry, with the one curve weighted path. Okay, so that is what we already get here. It is like 1 and plus 1. Okay, so this is nothing but the we got the result, and at the end we'll just find it like if we have anything value like inf is nothing but one constant in the math library we are using here. If we are having like it is not that constant, then we'll return this result value, either we'll return the minus 1. Okay, so first let me comment all this print statement, so we'll get the correct result and get all the test case satisfied. Okay. Okay, now let me again compile it. So okay, now it is fine, the first test case satisfied is fine. Let me submit it for the remaining. Okay, okay, we can say all the test case satisfies fine with this code. So this is the solution for today's problem of the day on Geeks for Geeks. Thanks guys for watching this video. Like, share and subscribe to my YouTube channel. Thank you guys.